Today we're going to focus on being able to determine the relationship between a central angle and the arc that it intercepts. So I have a couple of vocabulary words here. Concentric circles. Con means together. It's that prefix that means together. Concentric means they are circles that share the same center. Think like a bullseye, a target. A central angle, so when we talk about a central angle, we are talking about an angle that has the vertex of the angle at the center of the circle. So this is an example right here of a central angle. The angle would be angle AXB. We name our angles with either 3 letters or 1 letter. The problem is we don't know if I just say angle X, I don't know if I'm talking about this small angle or this big angle outside. So we need to name it with 3 letters. AX, the angle, which is the rotation. If you stand at X and you rotate, how much did you rotate? 360 degrees is all the way around the circle. So if you stand at X and rotate from A to B, then how many degrees did you rotate? Well, the same thing happens then. The central angle is equal to the intercepted arc. How many degrees is the central arc? We'll talk later in this semester about how long is it. I don't want to know how long is it. I just want to know how many degrees of the circle is it. That's what we're focusing on today. So one thing that's important about this and why concentric circles is important is if you notice, say for instance, that we're going to start with one side of our angle there and we're going to go with the other side of our angle right here. Pen's running out of ink. If this angle right here is degrees, okay, if the angle is 45 degrees, then this is 45 degrees of the small circle. It's 45 degrees of this medium-sized circle. And this is 45 degrees of that bigger circle. The 360 degrees is always 360 degrees, but it's 360. Remember is that the central angle is equal to the number of degrees in the intercepted arc. Not the length of the intercepted arc, but how many degrees out of 360 degrees is it? Okay, so let's look at a couple questions that have to do with this. So if the measure of angle AXB is 42, that means this angle right here from here to here is 42 degrees. If that angle is 42 degrees, then how much is the arc? Well, what you want to do is you want to trace out the angle and you want to see where is that intercepted arc. So arc A, know that when the vertex is in the center, the angle is equal to the arc, which means that arc AB is 42 degrees. It's 42 degrees of the 360 degrees possible. Major arc, this is a major arc. It has 3 letters, A, C, B. So you would start at A, you would go around the circle to C, and then B. Notice this is 3 letters, but it's not an angle. This is on the side of the circle. Think about the circle like a hula hoop. Okay, ACB, that's an arc. Well, it's everything except the 42. So we would take 360 and subtract 42 degrees. And we would find out that that arc is 318 degrees. Sorry, I don't like to do math in my head. So it's 318 degrees. Together, that minor arc and that major arc, since they make up the whole circle, right? Here's arc ACB. Notice that those two, that pink and that green together, take up the whole circle. Then that is 360 degrees. Okay, now what you want to focus on, I know it seems simple today because the vertex is always our way through this unit, the vertex is going to be in different places, and that's where you have to understand where's the vertex of the angle. So angle AXB is 114 degrees. So new problem, now we're saying that angle AXB is 114 degrees. And arc AB, the measure of arc AB, is 6x plus 16. Well, I know that the vertex of this angle is in the center of the circle. That means the angle is equal to the arc. So this angle, 114, is equal to this arc, 6x plus 6. So you'd simply set them equal to each other and do the algebra that goes with that. So 6x plus 16, the arc, is equal to 114 degrees, the angle. So do 114 minus 6, do that inverse operation. You get 6x is equal to 108. And we get that x is equal to 18. Again, the angle is equal to the arc. Now, As you're doing this, don't get confused between the angles and the arcs. Pay attention to the notation that you have. And then, as always, pay attention to where the vertex of the angle is. And don't forget semicircles. That time you see a diameter, if it appears to go through the center of the circle, it goes through the center of the circle. We're not going to draw something so close that it won't actually go through the center. So the center of the circle is K. So we would call this circle K. Big angle EKD is. So my question is EKD. So remember, we would start K and we would go from E to K to D. This is an angle, EKD. So I want to know how big this piece is. These are like puzzles, and you can start filling in the circle before you start filling in the blanks. We've got this 80-degree arc. This ED, the arcs are drawn, and it goes from end point to end point. So anytime you see a measurement like that, it goes from end to end, and it's in the middle. So this represents this arc. Well, this arc is a minor arc, and it traces back to a vertex at K. Is at the center of the circle, which means it's central. The angle equals the arc. So this angle equals that arc. So EKD is 80 degrees. Mark that right there. And then I want to know AKB, angle AKB. Angle AKB is right here. Angle AKB is that angle right there. It's not a vertical angle because its sides are not formed by opposite rays. Okay, so, but what we do notice is that this line right here, DB, is a chord that passes through the center of the circle, meaning that it is a diameter. Okay, so then that means this 80-degree angle and this 90-degree angle is 170 degrees. Then this angle has to be 10 degrees because those have to form 180 degrees. They form that straight angle. So we have 80 plus 90 is 170. Subtract that from 180 and you get 10 degrees. So angle AKB is 10 degrees. Arc CD. So we look for arc CD. Here is arc CD. Let's label it so we can see it. Arc CD. Arc CD is that part. Now every arc has an angle that goes with it. So if we start at our endpoints and we trace back until we hit a vertex, we end up at K, which is at the center of the circle. The angle is equal to the arc. Well, we don't have the arc and we don't have the angle. However, we do have, again, this diameter right here. Notice there are multiple diameters in that circle. So this is 180 degrees, right? Two together form a linear pair, form half a circle. The angle is equal to the arc. That's why half a circle is 180 degrees, because this angle here at K, formed by the diameter, is 180 degrees. That means that this angle right here is 100 degrees, which means this arc here is also 108 degrees of the circle. So it's 100 degrees of the circle. ECB, arc, the measure of arc ECB. Arc ECB starts at E, goes towards C, and has to end at B. So look at how you've got to go. E to C to B. What I notice is that I've got my sum, right? I can add my segment additions and how they go together, right? We can add these arcs the same way we add our segments. Plus, well, I need to know this BC, this piece right here. Well, that piece is formed by, right, it's intercepted by this vertical angle. That means this angle right here is 80 degrees, which means that arc is also 80 degrees. So now I can do 80 plus 80 and get 260. So the measure of major arc ECB is 260 degrees. So remember, it has to be more than 180 degrees. Now, angle DKC. Angle DKC, let's go back and find it. We already did, actually. Angle DKC, we talked about that. Because it has its vertex at the center of the circle, the angle is equal to the arc, so then the angle has to be 100 also. So we've got that 100-degree angle in the middle. And then the measure of angle ACE. The measure of EE. So the measure of arc ACE, we start at A, we go around to C, and we end at E. That's the only way we can go, is this direction. So A to C to E. A to C is all the way around the circle, except, so there's several ways you can look at the arcs and add them up, right? We know that this has to be a 10-degree arc because that was a 10-degree angle, 80-degree arc. 100-degree arc, 80-degree arc. You can do it that way and add those all up, or you can say it's everything except for this 90-degree arc. From A to E, arc AE is 90 degrees because angle AKE is 90 degrees. So that means that arc ACE is 270 degrees. It's 3 letters, so I know it has to be a major arc, which is more than 180 degrees. So let's look at some problems here. You might want to pause it and work these problems and see if they make sense to you, but these are kind of like a game. You just start filling in everything you know. That's the best way to do this. So we want CFD. So C to F to D is that right there. So we want to know the measure of that arc. Well, in order to know the measure of that arc, I need all of the angles that intercept those arcs. What I notice is that these two are vertical. Now, even more important than that, what I notice is that that is a diameter, right? That line BE is a diameter. Also that one, FC, that's a diameter. Don't forget to look for those diameters because diameters are 180 degrees. They cut a circle in half. So if this is 135 degrees, I can subtract that from 180 and find out that this is 45. If that's 45, this angle inside here is vertical, or that diameter is there too. Now I can add up all of those pieces, 45 and 45 plus 135, and you get that everything except for DC, right, CFD, the measure of arc, CFD is 306 degrees. Okay, now number 4, angle SPQ. Always start with a clear picture of what you're wanting to find. SPQ, angle SPQ. Because I'm asking for the angles, that means I need to know some things about the arcs because everything we're doing is arcs and angles. So I need to know those arcs, those other angles. So notice I have from U to Q, I have from Q to R, and I have from R to S. And I have that these two angles are congruent. If those two angles are congruent, then that means that UT is congruent to TS. So if I take 86 plus 154 plus 60 and subtract that from 360, I find out that these two together are 60 degrees. The arc is 30 degrees. Now I want angle SPQ, so I want from S 86 degrees. So 60 degrees plus 86 degrees is 146. So angle SPQ is 146 degrees. Notice that 60 plus 80 on the arcs is also. So arc 6 degrees, arc SQ is 146 degrees, and angle SPQ is 146 degrees. They represent two different things, but they are equal to each other. Okay? So on this one, pay attention to what you know, see what you're looking for, WV. I want WV, so I'm going to have to use the information that I have to find that. Well, anytime you get stuck, just start labeling everything that you know. I noticed that these two are marked congruent to each other, so I'm going to set them equal to each other. So that other angle is also 5x plus 10. Now, I know that the angles are equal to the arcs whenever the vertex of the angle is in the center. So this 5x plus 10 is talking about these two angles, and this 12x minus out here, but we know the angle equals the arc. And what I know is that this arc, WS, is congruent to this arc, VT. These two angles together, 10x plus 20, equal the arc that's intercepted. And I find out that this arc is 65. That means this arc, or this angle, excuse me, is also 65, and the arcs. This arc is 65, and this arc is 65. Well, T is a chord that passes through the center of the circle, which makes it a diameter, which makes that half a circle. So 65 and 65 is 130. Subtract that from 180, and you get that WV is 50 degrees. So these are like a puzzle. You just kind of have to work your way through, just start labeling everything you know so that you can figure out then how to find the piece that you're missing. On number 6, I am asking for angle VST. So in the end, I want angle VST. I want the measure of this angle right here. Well, in order to do that, I have been given arcs. The vertex is in the center of the circle. It means the relationship is that the angle is equal to the arc. Well, I notice that these two are marked congruent, so this is also negative 27x minus 3. Now, if you notice, you have 1, 2, 3 pieces. All 3 pieces of a circle add up to 360 degrees. So if I combine my like terms and add all of these together, negative 27 plus negative 27 plus negative 37 is negative 91x, and then negative 3 plus negative 3 plus 2 is negative 4, is equal to 360 degrees. Full circle, 360 degrees. So add, you get 364 divided by, you get that x is equal to negative 4. Now I know that you don't like that x being negative, but when you plug this in, when you substitute this in, we want it for that VST. So VST is the central angle for this arc. When you substitute it in, negative 27 times negative 4 minus 3. That negative times a negative is a positive. You end up with angle VST is 105. Coincidentally, not coincidentally, but also mathematically, arc VT is also 105 degrees. All right, last one. In circle K, angle HKG, HKG is right here, HKG, is x plus 10. Label that x plus 10. And over here, IKJ is 3x minus 22. So that's 3x minus 22. And I'm asking for the measure of arc FJ. So here's arc A. Well, obviously, we cannot find arc FJ straight out. We've got to find x first. So what I do know is that since these two angles are vertical to each other, so they are equal. So I will set 3x minus 22 equal to x plus 10. Vertical angles are equal to each other. I get 2x is equal to 32, or x is equal to 16. So once you know that x is equal to 16, substitute it in. So 16 plus 10 is 26. This angle is 26. This angle is 74 degrees, right? And then don't forget, because this HJ is a chord that passes through the center of the circle, making it a diameter. Because it's a diameter, we know that that is 180 degrees of a circle. So 26 plus 74 is 100. Which leaves 80 degrees as that central angle. And if that angle is a central angle, the angle is equal to FJ is 80 degrees of the circle. Okay, so the most important thing that you need to notice today is this, that the central angle is equal to the intercepted arc. The angle and the arc are always equal to each other when the vertex of the angle is at the center of the circle.